And this is the motif work. This has become a very well-used thing. The idea was they played around with the an E. coli network with actually not so many edges, of course, where you can see it's very, very sparse. But they did this thing of randomizing, taking this this gene expression network. They took this thing, randomized a whole bunch of times, and then looked at what was in the real one that seemed to be different from random. And so this is, they sort of famously got these three things out. The first one was these feed-forward loops, which is the kind of thing you find in opening an elevator or letting it close, right? So if X turns on, then that's going to start Y, and that's going to start Z, but Y has to turn on, right? So there's a delay in Z being turned on, and that's what this is, right? So X turns on, here's X turning on properly. So X turns on, Y ramps up, and then Z starts to get going. If X is only on for a little bit, Y starts, but Z doesn't really get going, right? So it requires it being on for a while, but as soon as you switch off X, then Z stops, right? So that's sort of this asymmetric on-off switch, which is, a good thing. So nature's produced this a lot, right? And we use it in our own electrical circuits. So that's a cool thing. And so, what they were able to do here is to say, let's look at every possible little collection of 3 nodes. And it's directed, so you count up all the possible things. And you look at the real one, the prevalence of certain kind of motifs in the real one versus what's in the randomized one, and you don't see this in the randomized ones relatively, right? The little z-score thing, blah, blah, blah. Very good. So that becomes hard, though, if you go to like groups of 4, 5, 6, you get a combinatorial explosion. There's work by Wiggins that tried to do that. Chris Wiggins is now the chief data scientist at the New York Times, and he's still at Columbia in the Data Science Institute there. So they found this, which is and they look for this, right? So master switch, X turns on, right? You don't find that in the randomized versions. And they didn't find these things either, which is just a mess, basically. But, this is something where they looked for certain things, and that's fine, but it's not the same as an exhaustive piece. Okay, that's fine. Okay, that's good.